Hello, ma'am. Just a quick check. Is my mic audible?
Yes, sir.
Okay. There's some issue with the speaker. I don't know why, but that's okay. I can hear you on the laptop. As long as I'm audible, that's fine.
Yeah, you are perfectly audible.
I'm also sharing my screen. Just let me know if it works.
Yeah.
I hope my screen is visible.
Yes, sir. Shall we start, sir?
Yeah, I think we can start with this.
Right. Okay, so let me introduce you to the gathering.
Sure.
A good afternoon to one and all present here, all the faculty participants, and our day 4 second session speaker, Ishan Roy, sir. We are really delighted to have you, sir, with us because it's a unique combination for teachers training program as you are dealing with the e-governance and blockchain in the state of Tamil Nadu. Ishan Roy heads blockchain initiative at the Center of Excellence for Emerging Technologies at Tamil Nadu E-Governance Agency. He contributed to and coordinated the formulation of Tamil Nadu Blockchain Policy 2020. He is currently working on Nambika Inayam, the Tamil Nadu Blockchain Backbone, and other e-governance initiatives. He has carried out the first blockchain remittance in India in 2016 at ICICI Bank. And since then, he has worked as the head of products at Hashcash Consultants, where he built blockchain-enabled financial solutions for global clients. In short, he is heading blockchain at Tamil Nadu E-Governance Agency, expert EU blockchain observatory and forum, and he is also blockchain author and authored the book Blockchain Development for Finance Projects. He has mentored students, executives, professionals, and industry veterans in blockchain technology with Upgrade, Eureka, and through independent workshops. So we are really delighted and honored to have you, sir, because your practical exposure will definitely very much beneficial for all the teachers participated from Madhya Pradesh and all over India AICT affiliated institutes. Over to you, sir.
Thank you, ma'am. Thank you for the kind introduction and thank you for giving me your time for making this presentation. Good morning, everyone. Welcome to this session on blockchain. I'm sure you've been briefed that today we'll be talking about consensus protocols and cryptocurrency. So that's mostly the area that we'll be delving deep into. A brief introduction, like ma'am said, I work with something known as Tamil Nadu E-Governance Agency, which is basically a trust that's held by the government of Tamil Nadu. We essentially help the government adopt various technologies, specifically emerging technologies such as AI, blockchain, etc., for bettering public service delivery. So building more and more better solutions for citizens and ensuring that the turnaround time for services is less. There's less scope for, let's say, corruption or for some service failure, etc. That's just a brief introduction. So coming to today's topic. So today, like I mentioned, we'll be talking about consensus protocols and cryptocurrencies. Just a quick check before I go ahead. Is my screen visible, ma'am? Are you able to see the presentation?
Yes,
and
sir,
I hope I'm audible.
Yeah,
great. So the first session, we'll be looking at what consensus mechanisms are. We'll be looking at some of the popular consensus mechanisms and which blockchain platforms use them. and how they change the blockchain platforms or what impact they have on the blockchain platforms. And lastly, we'll also discuss maybe a little bit about what consensus protocol is important to you, right? So if you're building a government platform or a government blockchain system, what consensus mechanism will you look at? If you're building a public cryptocurrency, what is the perfect consensus mechanism? If you're looking for speed, what is the consensus mechanism you should look at? We'll briefly discuss that. Second is a small section of cryptocurrencies. So cryptocurrencies, as you must have heard the buzzword for the last, I think, 4 years now. These are basically digital assets that are enabled using the blockchain infrastructure. And we'll briefly look at some popular cryptocurrencies, how you can buy and sell them, and why we are not able to do this without blockchain, and maybe what or how cryptocurrencies can be used in the day-to-day life in the near future. Okay. So starting with consensus mechanisms, I've been told that this is not the first session. So you have already had an introduction to blockchain. So I'm sure you must have learned about the peer-to-peer concept, or the concept of how there's a shared ledger in a blockchain ecosystem and everyone maintains a copy of the ledger. Every transaction is this ledger is interlinked using hashing, and every header contains the hash of the previous block. And because of these multiple copies of the ledger and the interlinked records between each ledger, we can make sure that the data that is captured to the ledger is maintained for time to come. It can never be modified. You can only add to it. And even when you add to it, an audit trail is maintained. You can never delete the data once it has been captured, right? So this is achieved using a peer-to-peer network, which means that there are various players who form this network. All of them host a copy of the ledger, and all of them have one hardware or multiple hardware that has this copy of the ledger. So as you must have learned, there are nodes, and then these nodes are talking to each other over the internet or the intranet, and they are constantly syncing up their copy of the ledger by trading transactions in a mempool or by broadcasting blocks, right? So why do we really need the concept of a consensus mechanism? Now think of it this way: when you work with a centralized database, so let's say MySQL, Oracle, Postgres, whatever you're working for, typically it is stored in one single server. So whenever you have to write to it or you have to read from it, there's just one location that you're interacting in, right? So if I have to, let's say I have a centralized database for maintaining accounts, if I have to add some information to it, there's just one copy of that database, or there's just one copy of that accounting ledger where I'll go and make an entry, right? And typically you will have a controlled set of users who can add to that ledger. So for example, if this was an enterprise system, only the accountancy team could go and through an application, they can enter the data into the database for the accountancy transactions. Not everyone will have the access. However, when you look at a peer-to-peer network like this, where that database has multiple copies and everyone has a copy of that ledger or that database on their hardware, how do you ensure that the ledger integrity is maintained, that everyone has the same universal ledger and everyone's copy of the ledger is always in sync? To do that, what we build is called a consensus algorithm, or rather what we count upon is called a consensus algorithm. So going back to what you must have learned about blockchain earlier, you have these multiple nodes and you have these multiple ledgers. Obviously, everyone can read from the ledger and everyone can write to the ledger. So how do you ensure that the writes that are being done to this ledger are uniform, which means that everyone has the same copy of the ledger? If a new transaction is added, the same transaction is added to everyone's ledger, right? How do you do this? So the obvious answer is to do this, we use a consensus mechanism. So very simply put, what does a consensus mechanism really do? It gives you an algorithm, it gives you a system through which you can choose a writer who will write to this ledger. Okay, so now what does this mean, right? So basically, let's say you have a blockchain network with 10 participants and you need to update the ledger, you need to add a transaction. If let's say all 10 people were writing at the same time, it would be very cumbersome, right? Obviously, you will have different copies of the ledger. So how do you maintain the uniqueness? So you create a mechanism. So for example, you create some sort of a challenge or a puzzle, and you say that the person who solves this puzzle, only he gets to write to the ledger. Another way could be you say that out of these 10 people, one person is the designated writer. Only he will write to the ledger at all times, or she will write to the ledger. The other 9 people will only read from the ledger, and that way the integrity is maintained, right? So broadly, two ways to do it. One is that you say that only one person will write to the ledger, or the second is that you create some mechanism for choosing that who will write to the ledger at one point of time. So just a footnote. So this writer, the person who is writing to the ledger, is typically referred to as a miner in Bitcoin or Ethereum. So you must have heard that some people saying that they do Bitcoin mining, they do Ethereum mining. So this is basically the process that they do, and we'll discuss again this in a bit more detail. Okay, so let's talk about how consensus mechanism basically works, right? So, and this is a generic architecture that exists across most blockchains. It might vary a little bit, but for 90% cases, this is true. So typically what will happen is that in every node in the blockchain, or every hardware that is hosting a copy of the ledger, you will have a section of the memory cordoned off, which is called a mempool. Okay, this mempool is basically a temporary pool of transactions. So these are unconfirmed transactions that can be added to the ledger. So for example, let's say 10 banks of India are running a blockchain network, right, where they are trading domestic transactions. So these are payment transactions. Now they need to decide that a transaction needs to be added to this ledger. So another payment needs to be carried out. So how will it happen? So they will broadcast a transaction to all the nodes in the network. In each network, there will be this section called the mempool. Within the mempool, all these temporary transactions will get. Yeah, is there a question? Yeah, is there a question? Hello. Okay, must be some disturbance. Anyway, so this.
No, sir, please continue.
Yeah. So this temporary pool of transactions will exist in every node. And what will happen is that whenever you want a transaction to be added to the ledger, you will submit it to your temporary pool, and it will get broadcasted to all the nodes in the network, and all the nodes in the network will have this temporary pool with unconfirmed transactions. So transactions that can be added to the ledger. Next step, what will happen is a writer is selected from these 10 nodes who will create the next block of transactions. So we'll add the next block of transactions to the ledger. So for now, don't worry about how the writer is selected. We'll discuss that later. But understand this, that there are 10 nodes with 10 mempools, each with these temporary transactions. And out of these 10 nodes, we create a writer based on some criteria. We select a writer. This writer will now go into the mempool. He will pick up the temporary transactions or the unconfirmed transactions that are there. And out of these transactions, he will try to build a new block, which will become the next block in the blockchain, right? So how does he select which transactions should be added to the next block? So there can be various ways to do that. So for example, in a government blockchain, obviously a transaction from the CM office will have more priority than a department transaction, right? Or let's say a regular day-to-day transaction will have less priority than a financial transaction. So the one way they can select which transaction to add into the block will be on the basis of what is the priority of the transaction, what is happening in the transaction. The other could be first in, first out. So based on timestamp, which unconfirmed transaction came in first, that will go out first. The third and very interesting would be fees. So if you look at public blockchain networks like Bitcoin and Ethereum, there, along with your unconfirmed transaction, you pay some fees to the network. So you pay some amount of Bitcoins or you pay some amount of Ethereum so that your transaction goes through. So if you pay more fees, basically you're tipping the miner, you're tipping the writer more, because this fees will go to him. So the more fees you pay, there's a greater probability of your transaction getting selected faster, right? So obviously the more priority your transaction is, if it's a larger transaction, you will tip more so that the miner or the writer picks your transaction first. Okay, so on the basis of this criteria, the writer will select these unconfirmed transactions from the mempool. Out of this, he will create a block. I'm sure you would have seen a block in the previous session. Otherwise, I'll also show you one. So he'll create a block out of these transactions. And then this block, he will first add to his copy of the ledger. So basically his database. and then broadcast to all the other nodes in the network. So now what will happen? The other nodes in the network will receive this block. So this write that has been made to their ledger, and they will check whether the transactions are correct or not, right? So what kind of checks will they do? So let's say it's a bank blockchain, right? And ICICI has posted a transaction where they are saying that 1 lakh of rupees is coming from a customer in Axis Bank to ICICI Bank. So Axis Bank, when they receive the transaction, they will check and they will say, "Arey, I have not sent a transaction like this. How are you adding a transaction?" So they can refuse the transaction, right? So they can say it's a transaction we don't agree with. So for example, another thing could be in the case of government blockchains, as part of some government scheme, you're crediting some subsidy or some amount to some citizen, right? And he does not meet the criteria. So let's say he's not in a poverty line or he's not from a certain community. So he's not due to avail that scheme or that benefit. So then the validator can reject. It could also be syntactical based, right? So the transaction format that you're submitting, maybe the time format is correct. Maybe how you have structured the transaction is correct. Right? So these checks the validators will do. One of the most important checks a validators do is they check the history of the transaction, meaning let's say it's a bank transaction and I received 1 lakh of rupees, then I'm sending 50,000 to one person and 50,000 to second person. So when the validator, when they're validating the transactions, they will check, okay, this 50,000 Ishandra has got from whom? So they'll say, okay, he got a 1 lakh transaction. Then they'll check, acha, this 1 lakh transaction came from where? So entire history of the transaction, very quickly they'll check, right? So validators do this very important thing where they check the audit of the transaction also to make sure that everything is in place, no fraud is happening. So this is the next step in the consensus mechanism. After the block is created and broadcasted, the other participants, the validators, check whether the transactions in the block are correct or not. And the criteria can depend on the application. So we discussed a few criteria for banking networks, for financial networks, etc. Okay, so now let's discuss, we very broadly discussed what the consensus mechanism is and how it works conceptually. Now let's discuss what can be the different type of consensus mechanism. Okay, so when we say what are the different type of consensus mechanism, what we are typically saying is that how do you select this writer? How do you select who will write to the ledger, or how many times he or she will write to the ledger, or what is the criteria for submitting a block, right? So on the basis of that, I have selected some 5 consensus mechanisms that we'll discuss in depth, or rather 5 I have put here. 3 you will see are more relevant to you because these are based on platforms that we deal with today. Number 4 and 5 were very prevalent a couple of years back. They're not as popular right now, but if it's required, we can discuss it. That's not an issue. Okay. So the first and by far the most popular conceptually is something called proof of work, okay, or POW for short. This is what is used by the Bitcoin network, and a small variation of this is used by the Ethereum network. I'm sorry, I forgot to mention earlier. Bitcoin and Ethereum network, obviously these are cryptocurrencies that I'm sure you must have heard about. These are also public blockchain networks. So what means is that these are blockchain networks spread out across the world, where anyone can run a node software and connect to this network. There are no barriers. So these 2 public networks on which these 2 cryptocurrencies are traded and applications are built are run using the proof of work consensus mechanism. And we'll discuss why proof of work, how it works, and why it's relevant to these 2 public chains. Right? The second consensus mechanism we'll be discussing is something called proof of stake. So proof of stake is a slight variation of proof of work. I'm sure if you guys have read about blockchain, or if you have read about Bitcoins, or in the recent past about NFTs or DeFi, you must have heard that Bitcoin causes a lot of environmental pollution. There's a lot of energy being burnt. There's a lot of carbon dioxide being released, and a lot of environmental concern has come, right? So proof of stake is basically an answer to that. It changes the work, it changes the mechanism of proof of work slightly so that the energy consumption is less, so that it's a green process. The third is called ordering, queuing, and validation. Okay, this is typically used in enterprise blockchain. So when I say enterprise blockchain, I mean blockchains being used by banks, blockchains being used by governments, blockchain being used by Telecom Regulatory Authority of India. So most enterprises or most private sector companies that are not dealing with cryptos, when they build a blockchain platform, they use this type of consensus mechanism, which is known as ordering, queuing, and validation. Okay, this is slightly different from proof of work and proof of stake in the sense that in proof of work and proof of stake, you have multiple writers, which means that there's a window in which the writer is selected, and we'll discuss that shortly. In this mechanism, typically the list of writers is limited. Okay, you already decide who are the participants who will write to the ledger, or you can create a block. If you think about it, logically it makes sense, because when you are running a government blockchain, who will write the transactions or who will broadcast the block, right, or create the block? So obviously it will be a government department, or obviously it will be like the IT department, or it will be someone who is handling the schemes. So you don't require everyone to write to the ledger, only certain participants. Similarly, in the case of banks, right, if let's say banks build a blockchain platform and you had fintech companies like Paytm, Cred, etc. on this platform. So who will write to the ledger? Obviously, only the banks will write to the ledger, right? Because or RBI will be an observer and they can write something to the ledger. So there'll be a limited number of writers. So these are typically used in enterprise blockchains, which are also referred to as private permissioned or consortium blockchains that you must have heard about in the previous session. Fourth is called round robin. This is now a bit extinct, like we don't use it these days, but a variation of this is still used in a blockchain platform called Hyperledger Sawtooth. This was very popular in a blockchain platform called Multichain, which was very popular 2 years back. So round robin, as the name suggests, is basically what happens is, let's say there are 10 participants and participant 1, 2, 3, 4, 10, and everyone has a node. So how will the system work? So first participant 1 will create a block, then 2 will create a block, then 3 will create a block, then 4, 5, until it goes to 10. Then in the next round, the sequence changes. So in this case, first 5 will create a block, then 6, 7, 8, 9, 10, then 1, 2, 3, 4, 5. So the sequence changes every time. And every round, everyone gets a chance to create a block. So this is a very democratic way of block creation, because almost everyone has rights to create a block, right? So this makes sense for most scenarios. However, from a security point of view, it's not very safe, because let's say if you know which node or which participant is going to write to the network, if you can guess the sequence, you can attack their node. So from a security point of view, it's not very safe, and this is not used much these days. Fifth is PBFT. So PBFT stands for Practical Byzantine Fault Tolerance Consensus Algorithm. I'm sure if you are computer teachers, you must have heard about the Byzantine Generals Agreement and Practical Byzantine Fault Tolerance. So this is basically that. This is a consensus protocol where you assume that 1/3 of the system is not corrupted. So you don't have like and the word for it is, you don't have like malicious nodes. 1/3 of the nodes are not malicious. Less than 1/3 of the node are malicious. If let's say the system has its limitations, so if the number of malicious nodes or the number of people broadcasting false transactions in the network goes more than 33%, this consensus mechanism fails. However, it's much faster than the other consensus mechanisms. Reason being that the way the voting happens is much more faster. The result generation is much more faster, and it doesn't require a mempool necessarily. You broadcast your own transactions. So it's much faster than the previous 4 consensus mechanisms. And you will see a lot of payment-based blockchains, like there is one called Ripple and there's one called Stellar, which focus on payments. So they typically prefer PBFT-based blockchains. Okay. So this is an overview of what blockchain platforms use these consensus mechanism, and then we'll do a deep dive into these protocols. So proof of work is used in Bitcoin, and the current version of Ethereum that we are running, which is called Ethereum 1.0, or generally just referred to as Ethereum. Proof of stake, or POS, will be introduced in Ethereum 2.0. So this is a new version of Ethereum that is due towards the end of this year. There's a blockchain platform called Dash, which also uses proof of stake. There's an Indian startup called Polygon, which is very famous. Their platform also uses proof of stake. Several layers are there. Ordering, queuing, and validation. This type of consensus mechanism is typically used in Hyperledger Fabric and R3 Coda. So these are blockchain platforms we typically use to build enterprise blockchain solutions. Round robin was used in an old blockchain platform called Multichain, and PBFT is used in Ripple and Stellar, which are payment-based blockchains. Right? So I hope no questions till now. So then I'll start delving deep into proof of work.
Any questions? You can either put it in a chat box or raise your hand.
Okay. So no questions, and we'll start developing into proof of work.
Yes, sir, you can continue.
Yeah, thank you. So basically, proof of work consensus is the oldest consensus mechanism that we have in blockchains. PBFT is older, but proof of work came with the Bitcoin blockchain. So with respect to blockchain, proof of work has been older. It started with Bitcoin. So I hope you have been told that this team or this gentleman or this lady called Satoshi Nakamoto built the Bitcoin system, and we don't really know who Satoshi Nakamoto is. So the inventor of Bitcoin is anonymous. We don't know who that person is. But anyway, when Satoshi Nakamoto, the person who built Bitcoin, was designing the Bitcoin system, what he was trying to do is he was trying to build a digital currency. So he was trying to build an asset that was not linked to paper currency. So the notes that we use on a day-to-day basis. Meaning that if you look at your bank account balance, right? So whatever amount you have in your balance or whatever amount is transferred to you or transferred out from your account, that is notional in the sense that there's some actual paper money or fiat money, as we call it, which is issued by the bank. And this, the currency of your bank is basically a representation of that physical money that exists somewhere, right? What Satoshi Nakamoto was trying to do is that he was trying to create a platform which could be used to build a digital currency. So it's a currency that is born on the digital platform itself. It doesn't exist outside of the platform at all. So for example, if I ask you to, if you ask me that, can you show me one Bitcoin? So I cannot show you one Bitcoin because it only only exists as an accounting unit on the Bitcoin ledger. It does not exist outside of that, right? So to build a system, one of the first problems he encountered is a problem called double spend. So what does that mean? So in your conventional currency, the currency in your bank, it is, like I said, it's linked to a physical asset. So somewhere, let's say if someone transfers 100 rupees to your bank account, somewhere in the banking system, 100 rupees is there. Let's not discuss where it is there, but a physical 100 rupees is there, which is, it is linked to, right? So when I say physical, I mean fiat, not necessarily fiat, physical. But in the case of Bitcoin, the accounting is the end of it all. Like outside the accounting ledger or the database, nothing exists, right? So this is problematic because let's say if I were to go into the core banking database and instead of transferring 100 to your account, I change it to 200 and there was a dispute, right? So if let's say someone says that I transferred 100, how did you get 200? We can backtrace and find that fiat and say that, oh, you are right, it was 100, it was not 200, because this exists outside the database. There's a way to check it. In the case of Bitcoin, if let's say I change the value on the database, there's no way to verify it because, I mean, your proof is the database. If the database says it's 200 instead of 100, I have to accept it. So this is known as, or rather a variation of this is known as the double spend problem, right? So how do you ensure that when your asset is mapped to a digital ledger, how do you ensure that no one is able to change the value of the asset because it's stored digitally? How do you ensure that it's immutable? It cannot be varied. So the other problem is that if you look at conventional banking system, right? So today when you use net banking, UPI, IMPS, etc., there are regulators and players on the network such as RBI and PCI, your bank, your beneficiaries bank, etc., which make sure that no fraud happens or no hanky-panky happens to as much as it's possible. But since Satoshi Nakamoto was trying to build a currency outside of regulators, he wanted to make sure that it was a system which did not necessarily need regulators to ensure that no fraud happens, or no one tries to change any value or send any fraud transaction, etc. So and obviously it needed to be an open network, which means that anyone can connect, anyone can send you money, anyone can receive money from you. So it's an open payment network. It's not restricted. Like in net banking, it's restricted. You have to do a KYC. Bitcoin is an open payment network. So for this network to operate efficiently, he realized that he will need a very effective consensus mechanism, right? So he will need a way to ensure that the people who are writing to the ledger or the people who are validating the transactions, they do not carry out any fraud, because in the case of Bitcoin, anyone can connect and be a validator, right? So they needed a system to make sure that any random person who joins the network cannot carry out fraud. So to solve this problem, he came up with the proof of work consensus mechanism. Let me just come back to the slide first later. So, and the proof of work is based on a system called, or rather the type of proof of work that Bitcoin uses is based on a system called Hashcash. Okay. So what does Hashcash typically mean? So let's say if I'll tell you typically how Hashcash works. So it was built as a anti-spam solution, right? So typically you will notice that anyone will come and they will spam your email with a lot of messages, right? And you will get irritated, you will get bothered, your email box will fill up. So to solve that problem, someone came up with this concept that if the mail that you have to send to me is really that important, I need you to do some computer work before you send me this mail. So what would he do? He would send them some mathematical puzzle. And the only way to solve that mathematical puzzle is to do some GPU processing. So to run a process, and only then you would find a solution. So for example, he'll give you like a cryptographic puzzle. And to solve that puzzle, your system has to do a lot of iterations. So it has to do a lot of calculations, only then it will get an answer. And he said that, okay, this is the Hashcash system. If the mail you want to send to me is really that important, I will give you a puzzle. Your computer has to solve that puzzle. You have to attach the solution to that puzzle with your email, and then you send it to me. My system will check whether the puzzle that you have sent is correct or not. It's the answer I required, and only then my mailbox will accept your email. Okay. So this is called Hashcash. This is the system that was devised by someone else, not by Satoshi Nakamoto. And Bitcoin also uses a variation of this system. Okay, so what does Bitcoin do? So Bitcoin says that, see, I have this open network with so many writers, so many validators, right? And I need to choose a way in which people can write to the ledger and transactions can be added to the ledger. So they said, let's do this thing. What we will do is every 10 minutes, we'll run a cryptographic challenge. We'll issue a challenge on the network. And the person who is able to solve this challenge within the 10 minutes first gets to add a new block to the network. Okay. So for now, let's just call it a cryptographic challenge. I'll get into details of what that challenge is. This challenge, the difficulty of the challenge is set by the network automatically in such a way that the probability of a person solving it in the 10-minute window is only one. Only one person can solve the challenge within 10 minutes. So how does the Bitcoin network work essentially? So every 10 minutes, a cryptographic challenge is issued to all the people who want to be validators on the network. The miners on the network will take the transactions from the mempool, the unconfirmed transactions from the mempool. They'll create a block out of these unconfirmed transactions. Then they will try to solve this cryptographic challenge. And the only way to solve this cryptographic challenge is that you have to do a lot of computing work. So basically, think of it as a random function, right? The only way to solve the problem is that you enter random numbers and see if the solution fits or not. So you first create this block with the transactions, and then you try to solve the puzzle. Whoever solves this puzzle first, he will attach it to his block and then submit the block to the network. So he'll broadcast it to the network and say that, hey guys, I have solved the puzzle within the 10-minute window and I've done some computing work. This is the solution. I believe this is the next block that should be added to the ledger, and he will add it to his ledger and broadcast it to the rest of the network. This process happens every 10 minutes. Like every 10 minutes, a new puzzle will be opened, and every 10 minutes, all the validators try to solve this puzzle. And if you created one block, does not mean you will get to create the next block. So every 10 minutes, it's a new challenge, and everyone can participate, right? For doing this work, for doing so much computation and validating the transactions, creating a block, adding it to the network, the miner gets a reward from the network. That's how the Bitcoin network is designed. This reward is right now, it's 12.5 BTC. Yeah. So they get around 12.5 Bitcoins from the network every time they add a block. Okay. And that is why they do it, because obviously 12.5 Bitcoins is a lot of money. Right. And obviously what has happened over a period of time is that because 12.5 Bitcoins is a lot of money and mining is a lucrative activity, a lot of people have bought complex hardware and fast computing machines, and which we'll discuss, ASIC rigs, which they used to do mining and create this block on the Bitcoin network. And as more and more people have joined, you will appreciate that the probability of this puzzle getting solved in the 10-minute window will reduce, right? So because more people with larger machines means that someone will solve this puzzle faster. So as a result, the network auto configures itself, and this difficulty for this puzzle has gone up. Okay, so now it's very difficult to mine. And since the difficulty has gone up, these machines need to do more computation because the puzzle is difficult. And because they need to do more computation, they are obviously burning more energy, more electricity, due to which we say proof of work is harmful to the environment, because these rigs are running a lot of electricity and a lot of energy, and for this proof of work has met a lot of criticism from around the world. This is just an overview. We'll do a deep dive also. So let's look at what that puzzle is, right? What this proof of work puzzle is that these miners need to solve. Okay, so I'm hoping in the previous session you would have read about blocks and block headers and body. So just to give you an overview, so every block in the Bitcoin blockchain or any blockchain has two components. The first component is called a header, which contains information about the block. Which information? So basically these 6 parameters. The first is the protocol version, which indicates which version of the Bitcoin software or the Bitcoin protocol are you using, because on the basis of that, the transactions are validated. Second is a Merkle root of the transactions. So Merkle root also, I'm sure you would know, or you would have read in the session yesterday. So this is like a hash of all the transactions in the block. Okay, so this is like a root, a Merkle root of all the transactions in the block that is created by hashing these transactions in pairs. Third is the timestamp, like when was this block created. Fourth is the previous block hash. So every block is identified through a hash. I'll show it to you also. So previous block header hash. So what was the hash of the previous block? Okay. Target is basically what is the difficulty of the network right now. Okay. So how difficult is it, or how easy it is? It is denoted by a number. We'll discuss shortly what this number is. And the last is something called nonce. Okay, so nonce is a random number that you vary to solve this cryptographic puzzle. Okay, so before I jump into the proof, let me first show you what a block looks like. Just one moment. Okay, so this website I'm opening is called blockchain.com. Basically, it's a Bitcoin Explorer. An Explorer is nothing but a software that allows you to see the blockchain. Okay, so right now we are looking at the Bitcoin blockchain. So you will see it says latest blocks. Okay, so this number, which is height, which is 695,382. This is the number of blocks. So this is the 695,382th block in the Bitcoin blockchain. Okay, and this was mined 5 minutes back. Okay, so let's open this block. Okay, so within the block, you will see that initially this some metadata is there. So this is the block header. Basically, it's a description of the block. Okay, so you will see first this hash is there. This hash is basically a hash of these parameters that are listed below. This hash, because it's unique, also acts as an identifier, as a serial number for the block, or rather index for the block. Okay, and this is the body of the block. So this contains the transactions that are there. Okay, so these are, each of these is one transaction. Okay, and you can see the fee is listed there, and you can see bitcoins are going. So this is a transaction for 6.53 bitcoins from this bitcoin address to these two addresses. Okay, okay, and just one correction. So I previously said the miner gets 12.5 BTC. So that was wrong. It gets closer to 6.25 because yeah, the halving has happened. So it gets closer to 6.25 BTC. The first transaction in any block you open is called a coin-based transaction. This is basically newly generated bitcoins that are credited to the miner's account. This is the miner's Bitcoin wallet, Bitcoin address, and he's getting this reward. And fees. So anyway, so this is the reward he's getting from the network for doing this mining work. Okay. All right. So now let's get back to our presentation. Okay. So now this block header and the block body you have seen at, let's discuss what this cryptographic proof is. So what happens is that every time a miner wants to add a block to the network and win this reward from the network, win 6 bitcoins, right? 6 bitcoins is a lot of money. It's around 55 lakhs today. So to do that, they have to solve this puzzle. And what is this puzzle? Essentially, they'll take these 7 details and they'll try to create a hash out of it. Okay. So what are the 7 details? First is a Merkle root of all the transactions. Okay. So I'm just switching back and forth between the index. So if you go here, you will see this says Merkle root. Okay, so some hash value is there. This is basically a hash of all the transactions, all these transactions, all the transaction details. We take it and we create a computer hash out of it. Okay, so the first detail is the Merkle root of all the transactions. Second is the hash of the previous block header. So the block that was there before this block, what was the header hash for that? Okay, so what was the identifiers for that block? So if you go up here, you will see okay, I think they've changed the format. It should have the previous block hash also. Okay, I think they have changed the format of the UI here, but it should have the previous block hash. They're just not showing it here. Okay, because it's a UI. In the backend, it will have the previous block hash also, which indicates that which is the block that came before this. The reason we do that is because this is how we create the linkage. This is how we create the chain. Okay, so because if it creates a hash of the previous block and it is stored immutably, you know that this block will come after the previous block only, right? That way you can ensure that the order is maintained. Third is block version number, protocol version number. Yeah, protocol version number, timestamp when this block was created, bits target. So the target is basically this number. Okay. So this integer number you see is converted into hexadecimal. That is the target. Okay, and we'll discuss what is the target shortly. And last is a random number called nonce. Okay, so you will see this number called nonce is over here. Now, what the miner tries to do is he tries to take all these details in the header and he tries to create a hash out of it. Okay, and when he creates a hash, what he does is he tries to create a number less than the target. Okay, so the target you will see here, it's an integer number. If you convert it into hexadecimal, you get a hexadecimal number. What he tries to do is he will try to take these details, add a random number and create a hash out of it. and he needs to make sure that this hash is less than the target. Okay, it has to be less than the target hexadecimal number. Now, if some of you are from a computer science background, you will know this is very difficult because hash is very random. Even if when you change a dot or if you add a dot, the value changes drastically. So there's no way to determine how to solve this puzzle or what is the answer to the nonce that will solve this puzzle. So how does the miner do it? So basically, they will take this detail, they'll put the nonce as 1 first, then they'll take a hash. They'll see, oh, is my number less than target or not? If it's not, then they'll increase the nonce to 2. Then they'll again take a SHA-256 hash. Then they'll see, oh, is it less than the target or not? Then again, they'll change the nonce to 3. They'll keep doing that until they get a number that is less than the target. Okay. So this process, this this work, they are essentially doing this random work. This is known as proof of work. And when they finally get a nonce, which leads to this header hash being less than target, they attach that nonce and they submit that block to the Bitcoin ledger and they broadcast it to the other validators in the network. This nonce is the proof that you have done some work. You have worked very hard to solve this puzzle, and you have finally solved the puzzle, and this is the answer, that this nonce gives me this a value less than this target. As you might realize, this is obviously very difficult to do, right? Because you have to constantly change the number and there's a 10-minute window. So to do this, what happens is that initially in the early days of Bitcoin, people were able to do this with the computer itself. So they would write these mining programs which would try to substitute this nonce and create a hash. And the more hash your system could create, or the faster your system was at generating hashes, there was a better probability that you will find the answer, right? So if you look at Bitcoin mining rigs, they're typically rated on something called hash rate, which is basically how many hashes can your system do in 1 second. Okay. And over a period of time, mining has evolved a lot. In the initial days, so this is 10 years back, people used to use laptops or even video cards. These days, what they do is they use these specialized rigs called ASIC machines. Okay. And ASIC machines only do one thing. They just generate hash. They are very specialized machines. They don't have much RAM. They don't have much storage. They just generate hash. And they're very expensive. You must have seen photos of ASIC rigs. If you haven't, let me show it to you now. Okay, so this is just one rig, but you will see people have like these large warehouses. So there are large mining companies, right? Like these, which have like, rack after rack of these ASIC rigs that are trying to generate these hashes. And recently you must have heard China shut down a lot of their Bitcoin mining rigs because of environmental concerns, right? Okay, so this is proof of work, and just a few points before we move on. So the person who is doing this, the writer, is called the miner. And when someone says they do Bitcoin mining, basically they're trying to do this only. They use a software that runs on specialized hardware to do this. One of the things is that the Bitcoin network is designed in such a way that every 2 weeks, the difficulty will go up and down based on how easy or difficult it is to find the block. So every 2 weeks, the Bitcoin software, what it does is it sees that how much time did it take to create the blocks, the last 2016 blocks. So on an average, in 2 weeks, 2016 blocks should be created, right? If ideally, if let's say one block is generated every 10 minutes. Sometimes what happens is that as more and more of these machines are added, a block is solved in 8 minutes, 6 minutes, 9 minutes, less than 10 minutes basically. So when the Bitcoin network sees that more and more blocks are being created in less than 10 minutes on an average, it will increase the difficulty of the network, which basically means that it will reduce the target number. It will reduce this hexadecimal number. So obviously you will appreciate that the smaller the number is, the more difficult it is to find a solution less than that number, right? If let's say it says that a block on an average is generated in 11 minutes or 10.5 minutes, that means the difficulty of the network is too high. It needs to go down. So then this target number is increased. So the bigger the number, obviously it's easier to find a number smaller than that, right? Probability grows up. Okay. Similarly for Ethereum also, this happens. Bitcoin, it happens every 10 minutes. Ethereum is much faster than Bitcoin. So this happens every 10 to, like, one block is generated every 10 to 19 seconds. So on Ethereum, this happens much faster. They don't wait for 2016 blocks, right? So they will see that what was the time taken to create a block. And if it is less than 10 seconds or more, they will increase the difficulty, meaning the target will go down. If it is more than 19 seconds, that means the difficulty is high. So the target will go up. Okay, this is Ethereum. Okay, just a short note on ETH hash before we move to proof of stake. So ETH hash is the consensus mechanism used by the current Ethereum network, Ethereum 1.0, which is being used. It's probably the second most popular proof of work algorithm in the world right now. It's similar to Bitcoin except for one change. So if you remember, I was talking about these ASIC machines, these specialized machines that have less storage, that are used to do mining, right? So when Ethereum was created, they realized that there were these lot of large miners with a lot of money who were doing mining work and earning a lot of money. And the common people are cut off from the mining process. So to solve that, what Ethereum said is that we will make our consensus protocol ASIC resistant, meaning that you cannot mine our consensus or you cannot create blocks on the Ethereum network with ASIC machines. So how did they do that? So every 30,000 blocks, and this 30,000 blocks is called an epoch, they generate a random data set based on the previous block, which is called a DAG, or directed acyclic graph. And every 30,000 blocks, the size of this data set increases by this formula. Okay, so this formula, you can look at it. It's not very relevant right now, but by this formula, they will see, okay, what is the epoch index, which means what is the number of epoch running from the starting of the blockchain, and they will slowly increase the data set. Right now, it's around 4.3 GB. Okay, so because this 4.3 GB, you require a lot of, because it's 4.3 GB, you require significant storage to do the mining work, because these components from this DAG need to be included in your mining solution. Okay, so like in the Bitcoin case, you had the cryptographic puzzle you had to solve, you had to provide a nonce. Here you also have to provide a few components from the DAG data set. So obviously, if you have to hash very fast and produce solution very fast, you need to constantly hold it in your RAM, right? And ASIC machines cannot do that. They do not have that much ability. So that's why this is ASIC resistant. Okay. Okay. So that was a proof of work. Any questions? Otherwise, I'll move to proof of stake. Okay. So moving on. So as you have heard that because of proof of work, there are a lot of environmental concerns. People are saying that so much electricity is being used, and Bitcoin network consumes electricity equivalent to a small country like Georgia, Jordan, etc. Because of that, or as a response to that, a consensus algorithm was devised called proof of stake. What happens in proof of stake is that in proof of stake, you go to the network participants who own some coins, right? So like in the case of Ethereum, who own some ethers, and you say, okay, what we'll do is that we'll ask you to keep some cryptocurrency on stake, right? So let's say you have 32 ethers, or you have, and 32 ethers is the cutoff for Ethereum, but you take some significant amount of money and you lock it in a smart contract. So think of it as an escrow account. You lock it in an account. And if you do that, if you put some money on stake, you don't have to run this specific machine and run so much electricity. We'll allow you to be a validator and a writer on the network. And whoever puts this money on stake, what we'll do is randomly we'll select a person to create the next block, right? So typically it's a lot of money. Like in the case of Ethereum, the cutoff is 32 ethers. And one ether today is around 2 lakh, right? So it's a lot of money. Not everyone has that money. So this means that it's typically people who have been there in the network for a long time, who have been, with the network, participating in the network for a long time. So what happens is they transfer their money to these accounts, which are known as staking accounts, and there the money is locked for some time. And depending on how much they have staked, they get to become a validator. So they become to writer on the network, and they are chosen randomly. Whoever stakes is chosen randomly. There are variations to this. One of the variation is that in some cases there will still be proof of work, but your mining difficulty will reduce based on how much you have put on at stake. But generally, most versions that we are hearing about now, or which have been implemented on now, there's no proof of work at all. It's basically how much currency you keep at stake, and on the basis of that, on random, a validator is generated for every block that has to be created. To be malicious on this network, you have to own 51% of all the cryptocurrency, right? Which is very difficult. And if you manage to do that, that means the network is not decentralized. So the philosophical concept behind this is that if there's someone who owns 51 ethers, 51% ethers on the network, there's no use being on that network at all. That means we'll all lose the money. That person will be the landlord, he'll take advantage of you. And there's no block reward as such. So like in the case of Bitcoin, you saw that for doing proof of work, they get some bits. Bitcoin, in case there's no block reward, basically the people who want to transact on the network will just pay a fee, and the person who is doing the validation will take that fee. Okay. So this is an overview of proof of stake. Basically, the creator of block is chosen according to how much wealth they have and how much they put at stake. Obviously, if they try to approve some fraudulent transactions, or they are fined, that stake is fined, they are penalized for that. And they receive transaction fees, but there is no block reward as such. And obviously, this process requires less computational power because you are not trying to solve a puzzle over there. So this is just a broad overview of Ethereum. So Ethereum is moving from proof of work ETH hash, which we discussed, to something called Casper, which is a proof of stake system. This is a brief workflow, which is basically the same thing that we discussed. Okay, just a word of caution, because 2.0 is still being implemented. It might vary. What will come at the end of the year might change, but broadly, this is how it is being implemented. Right, I see two questions over here. Achha, it's a feedback form. Okay, so let's look at our last consensus algorithm in depth over here, and then we'll discuss cryptocurrencies briefly and close and see if there's any question and answer. So this consensus protocol is called endorsement, ordering, and validation. This comes from a blockchain platform called Hyperledger Fabric. So this is a blockchain software, you can think, which typically we use for enterprise applications. So when we build a blockchain for governments, for banks, etc., we typically use Hyperledger Fabric. You can think of it this way, that when you are writing a program, you can write in Python, Java, JavaScript, etc. For a database, you can use Oracle or Postgres. So similarly, in a blockchain application, you can use either Bitcoin, Ethereum, Hyperledger Fabric, etc. Hyperledger Fabric, Coda, these are mostly used for enterprise applications. So here the consensus protocol is a three-step process, which is called endorsement, ordering, and validation. To explain to you how consensus works over here is that basically, let's say you have a insurance blockchain, okay, and where you are saying that there are smart contracts that issue contracts for insurance. So in that case, what will happen is, imagine this network is there where one of the participant is you, who is trying to make an insurance claim. The other participant is your hospital, and there's a third participant, which is an insurance company. So you will come and you will submit your claim saying that I went to the hospital, this is how much money I spent, this is what happened to me. And let's say company A is your hospital, company B is, for a moment, let's say the insurance company. Okay, so you will submit it to a client app. Let's say this client app, which is your insurance company's app, and company B will check with company A that whether this is valid or not. So were you actually hospitalized between these dates? Were these the medicines given to you? Did you book this room? Was this person your doctor, etc.? So they'll do a check with company A. And company A will check and then say, yes, these are correct. These are correct details. You can proceed with this claim. So this process where this check happens is called endorsement, where basically the various participants who are involved in a transaction are endorsing that this transaction is correct, or they are saying this transaction is incorrect. It should not be added to a ledger. Next, what will happen is that this transaction is taken and it is broadcasted to a very special node on the network. This node is called an orderer or an ordering peer. So this node is a very dumb node. It does just one work in the network. What it does is it will take all the transactions coming from the various participants in the network, and on the basis of FIFO, first in, first out, it will order the transactions in a block, create a block every 1 second or 5 minutes, depending on how the network is configured, and then broadcast the block to all the participants in the network. So only one writer is there in this consensus protocol, which is this order. Okay. So this block is broadcasted to all the participants in the network, and then these participants will receive the block from the orderer. Before they add it to the ledger, they'll do another check. So company B will check whether the transaction added in the block is the correct one, right? So it is the insurance claim made by my customer, the details provided by my customer, etc. And once it verifies, only then it will add the block to their ledger and update the state. And when I mean update the state, basically pay your insurance claim, pay you the money. Similarly, the hospital will also check whether the details are correct or not, and only then they will update their state saying that this person was there from, let's say, 11 July to 15 July, and this is an insurance claim, and we have verified this is correct. Only after verifying, they'll add the data, right? So this is a 3-step process. The first is endorsement, where a pre-check happens. The second is ordering, where the orderer creates a block based on FIFO. And the last is validation, where after the block is created, these will check whether the block that has been broadcasted is correct, and only then the post-processing will happen. So this is a brief flowchart, establishing what we just discussed. You can probably look at this after the session if you want to revise. Okay, so the ordering that happens in Hyperledger Fabric can be through various means. So obviously, see, you cannot have one node running like this in enterprise in all the cases, right? So for example, in the case of banking transactions in India, there you can say that there will be one order node that is run by the RBI. But in most cases, you can't have just one person creating the block, right? Because you have different participants. So depending on the participants, everyone would want to create blocks. So to do that, there are various ways you can set up orderers on the network. The first is called solo, where only one orderer runs in the network. So the example of this would be a banking blockchain where only RBI is running one node that is writing to the network. The second and third is implemented through something called Kafka and Raft. So in this case, there are multiple orders and they take turns writing to the network. So in the first case, basically, there's like one lead orderer, and if that fails, a second orderer will come in and take its place. And there's a history that is maintained on a zookeeper queue. And the third case, this is simply just a decentralized organization with multiple orders. Both of these are done just to make sure that everyone gets a chance to write to the ledger and the network is crash tolerant. Like if in this case, in the RBI case, if RBI's node is attacked, the network will stop working because no one can create blocks. But in this case, if a node is attacked, the network will still continue to work because other participants can take over, right? So there are two different iterations, Kafka and Raft, which are applicable, and depending on the situation or the architecture, we might use Kafka or Raft. Mostly Raft is more popular. Okay, so before we close consensus, just one more thing. So there's a blockchain called Quada as well, which is a very famous enterprise blockchain. This is again similar to Hyperledger. In their case, they call it a verification consensus and a unique consensus. So validation happens two ways, where first you validate and all the relevant parties are certain that the transactions are correct. And the second is that once the transaction is added, they check whether the transaction is unique, that the change that happens or the details that are added, they are correct. So basically in the previous case, this would be validation, where you are checking whether data that's added is correct or not. And instead of orders, you have notary clusters over here, which basically create blocks similar to Hyperledger Fabric. Okay, just an overview. Okay, so this with this we come to the close on consensus. We'll briefly look at cryptocurrencies after this. Any questions till now? Okay, if no questions, then I'll proceed. So basically, what is cryptocurrencies, right? So the concept is essentially that you are creating a digital currency or asset that does not exist outside of a decentralized ledger, right? So like we talked about earlier, when we talk about your net banking system, the balance that you have that is fixed, that is linked to some fiat money, money that is issued by the government. In the case of cryptocurrencies, this money does not exist outside the ledger. It is born on the ledger. In certain cases, it dies on the ledger as well. It is burnt when there's inflation, but it doesn't exist outside of the ledger. And because the ledger is immutable, we all trust that these details will not be altered. They'll always remain the same, and the system can be trusted. The reason we were able to do this is because Bitcoin, which is the first cryptocurrency, it had a solution for the double spend problem, which we discussed earlier, in which you are able to create assets on a digital ledger without depending on fiat money or money issued by government or a regulator. So that led to a huge revolution where everyone started creating assets or currencies that were mapped to these immutable ledgers. And Bitcoin itself was born out of a requirement to build a cash-like currency for the internet. So today, when you use net banking or when you use Visa or payment gateway for payment, you're still relying on money that is issued outside outside the digital realm. So it is issued through a RBI policy, etc. Okay, so Bitcoin was born out of the need to create a cash-like currency, meaning that when you, for example, if you go to a shop and you buy something, you directly pay them cash. You're not dependent on a middleman. Whereas if you try to buy something on the internet from Amazon or Flipkart, your transaction will go through your bank, through a payment gateway, through Visa, MasterCard, and then to Amazon. So there are multiple people. What Bitcoin was trying to do is, can you create a software where you can directly pay the merchant and the merchant can directly pay you? So for example, when you buy something with Bitcoin, so for example, if you buy a Tesla with Bitcoin, you directly transfer the money to Tesla's account. You don't go through Visa, MasterCard, etc. Right? So that is what Bitcoin was trying to do. And this allowed us to create an ecosystem where you can issue as assets where transactions are recorded on a universal ledger. These are transparent, immutable, and pseudonymous. Pseudonymous meaning that on the Bitcoin network, I may know your account, but I don't know who you are, right? So I can trace your transactions, but I can't link it to your real world identity. The ledger is stored in multiple nodes, so anyone can go and check. It's transparent because of the peer-to-peer nature and the linking between the blocks. The transactions are immutable. Yeah, so this is the double spend problem that we discussed earlier. Basically, previously before blockchain, I can send the same money to two people, right? Let's say seller A and seller B, and later they will realize that I have duped them or I've done some fraud. But because of consensus protocol, this double spend problem is solved, right? Only one person will receive the money. If I try to spend the money twice, then the validator will catch my transaction and throw it out of the block. They will say that this is a fraud transaction. They will not allow it to be added to the block or to the ledger. Okay, this is a broad classification of cryptocurrencies. This is broad in the sense that, I'm not saying that these are 7 different types. A lot of these properties are applicable to multiple of these cryptocurrencies. You can think of these as properties of different cryptocurrencies. Okay. So the first is something called native cryptocurrencies. So these are cryptocurrencies that are native to a particular blockchain, meaning that they are born on that blockchain. And typically we use it to create transaction fee or to carry out other operations on the network. So the oldest example is something called Bitcoin, which we call a UTXO cryptocurrency, which I'll not get into much detail right now. The second is Ethereum, which is also born on the Ethereum blockchain. An old terminology we used to use is something called altcoins. This has various meanings. The most popular one is that these are coins that are derived from the Bitcoin code base. So they use the code of Bitcoin, except that they run a different ledger. So it's a different network, but the exact same code as Bitcoin. So Litecoin is an example, Dogecoin is an example, multi-chain is an example. These are altcoins that were derived from Bitcoin. Third is you have privacy preserving cryptocurrencies. So these are cryptocurrencies where I cannot find out how much money has been sent to you or how much money is received by you. The only thing the network does is establish that you've actually received this money or you have sent this money, but an outside person cannot find out how much you have sent or received. So the two popular such platforms are Zcash and Monero that you can look at. Zcash uses something interesting called Zk Stars. You might want to look at that. There are privately owned cryptocurrencies. So these are issued by either non-profits or even profitable companies. So popular examples are Facebook, which is issuing Diem, which was previously known as Libra. There's also Ripple, which is issued by a company called Ripple. Then you have the concept of tokens. So these are basically not exactly currencies, but assets that are issued on top of an existing network. Most popularly, this is done with Ethereum. So if you have heard of the terminology ICOs or NFTs, so ICOs are tokens that are issued to raise money for some project. It's like a IPO you can think, or a Kickstarter you can think. NFTs are non-fungible tokens. These are basically tokens used to refer art, etc. Stable coins are cryptocurrencies which have a fixed value, so they're typically pegged to a certain currency. So for example, USDT, USDC, they are pegged to the value of US dollar, right? So if you try to buy USDC or USDT, it will be equivalent to buying US dollar in crypto. Equivalent in the sense that in monetary terms. So they are around 75 rupees to buy one USDC approximately. DAI is similarly another stable coin whose value is near the value of US dollar. So unlike the other cryptocurrencies, the value of these doesn't change. It's pegged to one currency, right? So if you have heard, and the last one is CBDC, which stands for Central Bank Digital Currency. So a lot of governments are trying to create their own cryptocurrency. So for example, Cambodia has created their own CBDC, which is basically instead of issuing like fiat money, they've issued it as a CBDC, as a cryptocurrency. Similarly, India also, last week only RBI has come out and said they are researching how they can create a CBDC. So basically, Indian rupee, which is like a cryptocurrency. Singapore is looking into it. There's a digital euro project which is also looking into it, etc. So I'll just pause here. This is the market cap of various cryptocurrencies, and you can see right now Ethereum is the biggest. I think, okay, surprisingly, it doesn't have Bitcoin. Bitcoin will be over this one. So this is as of 7th Feb 2021. You can go to coinmarketcap.com to see what is the value today. Something important to understand is, and this is a question I get a lot of times, how do you decide what is the price of a cryptocurrency? So the price is determined by trading on various cryptocurrency exchanges globally. And there's a notional price, that what is the price of this currency, and then there's demand and supply. So like the price of a stock is established by trading on Nifty, on NSE or BSE. Same way, cryptocurrencies are traded in cryptocurrency exchanges like CoinDCX, SEPA, etc. And on the basis of that, the price is determined. It varies across the exchanges also a little bit, but more or less they are close. So just to summarize, cryptocurrencies or crypto assets that are distributed initially as mining rewards to miners, or they can be distributed in the community. So for example, if I start a blockchain and I want people to use my blockchain code base, I'll give them my cryptocurrency for free, which is something that Stellar has done, Polygon has done. I think Ripple used to do it initially, a lot of people have done. And it can be exchanged for other assets. So for example, if you want to buy Bitcoin, you can go to a cryptocurrency exchange, pay Indian rupees and buy Bitcoin. They can be bought and sold at cryptocurrency exchanges. So these can be centralized or decentralized, meaning that there's one company running it, or these are blockchain based. So Coinbase, Binance, Kraken, Bitstamp are popular global exchanges. WazirX, Coin, BCX, Unocoin, Zeppay. These are Indian exchanges which are very popular if you want to explore. They can be held in crypto wallets, which can be software, hardware, or memory. So software basically means that you use some sort of a software to store a private key that can be used to access your crypto funds. Hardware means that you use like an encrypted USB device, right? So like which has your private key, and these are called hardware keys. Lastly, you can also remember your private key. This memory, this is typically called a memory wallet. One of the popular crypto software wallets is something called MetaMask, which is available as a browser plugin. So let me show it to you. This is MetaMask. It's basically available as a browser plugin, and then just log in. So this is my Ethereum wallet. Okay. So you will see there are various wallets over here. So this stores my private key securely, and I can send and receive funds from it. Right. So with that, I come to a close. If you want, I can take any more questions you have. If you want to know more about blockchain, dApps, DeFi, you can also check out my book. It's available on Amazon, backed by Ben O'Reilly. It's called Blockchain Development for Finance Business. So thank you. Any questions, I'll be happy to take them, or we can bring the session to a close.
Thank you very much, sir. It was really very interesting session. And as it was all related to cryptocurrencies and finance aspects, and you have practically shared everything and all the resources. So that was a really very nice experience. This teachers training program is really a hectic one. Every day we are having 4 sessions. So to grasp really all the things within this short duration is a little bit difficult. So I call faculty participants, if there are any discussions, any doubts, please come forward. We are also having some of our research scholars. So students, if you are having any doubt, but definitely you have given us a very clear-cut direction to move ahead. Otherwise, we just know a bit about Bitcoin. That's it.
Right.
So it was really a great view towards all these concepts.
Thank you, ma'am. It was a pleasure for me as well.
Yeah, on behalf of LNCT MCA, once again, I'm very much thankful for you to spare your valuable time, because I do understand you may have a very busy schedule dealing with all these things.
Right.
So it was
a pleasure, ma'am. I always love talking to students.
Right. Thank you.
Thank you.